This is the Amp Hour Podcast. Released May 7th, 2023. Episode 631. A Noisy, Rude Bus.
Welcome to the Amp Hour. I'm Dave Jones from the EEV blog.
And I'm Chris Gamble of Contextual Electronics.
As always.
Yeah. I was watching your 10 years of...
dumpster diving.
Digging through the dumpster diving. And you know what the number one thought I had was...
What?
Where did all that crap go? Do you actually put it back in the dumpster? Because I really hope you do most of the time.
Very, very little of it goes back into the dumpster.
Wow.
Like the computers and the monitors and stuff I keep, give away, use. Like I'm using dumpster computers at home, here, everywhere, you know.
Huh.
So
yeah. Bitcoin mining. He's still doing it. One person. He's the last person. He's the last holdout.
Right.
Just because he finds so much crap at the dumpster room.
A lot of them are stockpiled. You know, I've got a lot of, even though I keep, I gave away 15 monitors once, and then I gave more away when I moved the labs. I gave 15 computers, like small form factor computers, away when I moved lab last time.
Hey buddy, you want to buy a CRT?
I've still got the two CRT TVs. They're kind of handy for old school retro stuff, things like that.
Sure.
I'm using a network switch I found in the dumpster. I'm using a couple of network switches I found in the dumpster.
Yeah. This is
what
I'm going to recall next time you complain that the lab's really cluttered as well.
Right.
Yeah.
Well, that's why I've got two storage units.
Yeah, exactly.
Yeah.
Exactly.
Well, the chair I'm sitting on now, found in the dumpster.
You should just move the sign for the dumpster room to your storage unit.
Right,
Dump
exactly.
it directly in there. Yeah.
They have actually installed a camera in there now. After the signs threatening to do it for like a year and a half or something, there's finally a camera in there.
Are they real? I always love those kits you can buy where it's just a blinking LED.
I did actually trace the camera, and they've got one inside, they've got one outside, and it's tied into it turns out that it was, the reason I didn't know about it is because it was installed by the building next door, which also has access to the same garbage room. And they have a different strata committee, because I'm on the strata committee for this building. So there's no way they would have expensed it and installed it without me knowing. So I wondered how or why they did this. And it was the building next door that paid for it. So yep. So they must have been having issues. Their strata committee got fed up or something with people dumping so much crap there, but they upgraded the whole security system for the building, so they got cameras all over the place now for the building next door. Whereas
it is really easy to upgrade security systems now with Wi-Fi sensors and all the little thread and all the different sensors that are out there.
But these ones are all wired.
Ones.
So I actually followed the conduit.
Yeah.
I followed the conduit along. They screwed it into the concrete roof right
that
through
is the
the
right
underground
way to
car
do it.
park. And
if you really want to do it right, that is definitely the right way to do
totally.
it. But there's a lot of.
Well, you need power, right? So it's like, you're going to have to install it where there's power if you're going to get the Wi-Fi thing. You can't just magically install the Wi-Fi thing, right?
Well, no, a lot of the Simply Safe and other ones that are kind of popping up, at least in the US, a lot of them are battery-based sensors, and then they'll be Zigbee or
but you can't have a camera. You can't have a camera with a battery-based
Although,
thing.
no, actually, they are doing, that is actually another thing, too. I've been surprised about that, because I looked at this for my house, actually, and there's a Nest camera that's wireless, and I was like, how the hell, there's no installation. Okay, fine, whatever. What you do is you basically, it's like this magnetic mount, and then once every, I guess during daylight or whatever, you pull these things off their mounts and you go plug them in, and then you charge them up and they come back out. And it's that's
but how long is a camera going to last on a charge?
I don't know.
I mean, that's just BS, right?
Yeah, I didn't buy it for a reason.
Right. No, I just can't picture that working. That's just dumb. And if you want to install something like that, you don't want to have to maintain it. You just want it to.
Yeah, I think that's right. You want it to be
like
an appliance, right?
Set and forget. Yeah,
totally. Yeah.
Yeah,
Agree.
Yep. Yeah, you can install, per motion sensors. You install like a CR123 battery in there, and it lasts 5 years or something. It's fine.
Yeah, exactly.
But no, a bloody camera. No.
Yeah, like read relays and motion sensors and stuff like that, where it
Yeah.
actually activates and like cuts off the switch otherwise. Yeah.
Mm.
Yep. Yep.
Yeah, no. All right. What have you been up to?
I've been wait, let's see if I can turn it on. I've been writing music, Dave, for a demo I made. Here we go, ready?
Yep. What? Is that it?
That's it. Yeah, so I've been working on Thingy 91, which is like a little platform for Nordic for their selling.
Right.
And they have a buzzer on there. It's just a little piezo buzzer.
Yeah.
But like there are no examples on the entire internet. And I was like, I'm gonna go make some examples for this. And like I was making demos for work.
Yeah.
And so I guess I should probably turn it on and get the other ones playing.
So
too.
so it's an actual buzzer at a fixed frequency. It's not a piezo transducer which you can operate at any frequency. Which one is it?
It's the latter, yeah. So it's like a NPN driving a piezo that you can drive.
Right.
A
Okay.
pin,
So
basically.
in theory, you can drive it at any frequency. Okay. Right. So it's
so
not
that's
a buzzer.
Why...
A buzzer.
Oh, interesting. Oh, I didn't know
buzzer
this. Okay.
is defined. Yeah, a buzzer is defined as something that has its own internal oscillator and it oscillates at one frequency. It just buzzes at one frequency.
A piezo.
I would call it a piezo transducer.
Transducer. Okay.
Yeah.
That's great. Okay, so this is a piezo transducer.
Right.
And I've been using this thing to just make some silliness, and
sweet.
It's been pretty good fun. Triggering stuff from the internet, of course. It's basically the most trivial internet machine I could make. So
right. Yeah.
among many other things that it does, but that's the most trivial part of it for sure.
Right. So is that the extent of your musical skills at the moment? I thought you were an actual muso, dude.
Well, I had to actually, because it was just like, I had to like set up kind of like a framework for it, because it's literally when you do a piezo, it's like, when you do a PWM, it's like, well, okay, you give it a period and you give it how much duty cycle it is, and that doesn't really translate to like notes.
Yeah, right.
So then I had to go and like write this node is this, and so I put in all the
so
notes.
You've got a note library, a note table
right, exactly.
or something. Okay, so you can choose your notes. Okay, right.
Yeah, exactly.
That makes sense. Exactly. Rather than write a whole lot. You could have a library that takes in a waveform or something, and then
Yeah.
So in theory, you could actually make that talk. So
yeah, exactly. If I like learned phonemes and like did all that sort of stuff, like I could go pretty insane with this sort of thing. But I probably will stop at a certain point. All right, let's see if the internet part works. Yeah, all right.
It's very old school Merlin. I've done a video on that old school Merlin game from the 1970s, which used the world's first microcontroller. And
okay.
It's
right.
I'll try and get that video.
Okay. I mean, that was the Mario theme, right? That it wasn't very well done.
I
don't know.
Sorry.
That was the Mario Brothers theme. Okay.
Oh, okay.
And then I also did this one.
Got it.
Unfortunately, like part of my lab does not. Oh. Well, that didn't quite catch it, but that was Funky Town.
All right.
As you do.
Got it. Anyway, I sent you the link to the Merlin. Yeah.
And then I pretty much got bored with like putting in new songs. So, but I have the framework now, so I could put in other stuff.
Cool.
But monophonic, and so
right.
I wrote a little song, and
Groovy.
I put in 2 covers, and then that's about it. And then I moved on to the other stuff I had to do with it. Yeah. But they're triggerable over cellular from the internet, Dave. So that part's actually pretty cool.
Right. Is there like an online tool that you can put, like you can just give it a song and then it gives you the notes out? Is that like a thing? Surely there is.
Well, I tried that with ChatGPT and it didn't quite get it right.
Okay.
The easy way to do that, I think, is like just go and look up sheet music. But of course, you need to like read sheet music, which I do. Right. But other people might, if you don't have that experience, you might struggle with that.
That's why I'm thinking an online tool that can just spit out notes. Oh, it's a B, G, A, or
yeah, I bet you could find something that would do that. I was actually looking for something. I was looking to see if there was other AI services. Of course, we already got into AI. I was looking for other AI services to see if it would like write me a song. I tried like make it sound like a John Williams-esque theme. Basically like a mid-journey for music. And apparently that is coming. Google has some demo. There's like a bunch of demo stuff out there, but none that are like services where I can just type stuff in and have it spit something out, which is fine.
Interesting.
But it is on the way. I forget what it's called for Google.
Right.
There's so many repeating elements in music, and there's actually like a court case that just concluded where Ed Sheeran's like a pop singer, and
Yeah,
he was being
I know
sued
who
by
Ed
the
Sheeran.
estate of
Yeah,
Marvin Gaye.
copying something or what?
Yeah, they said that one of Ed Sheeran's songs sounded like "Let's Get It On." So
I don't know it, but okay, right, right. So they're claiming it was, yeah.
yeah, they're claiming that, and like, and it's interesting. There's a couple Adam Neely videos about it, who's like a music YouTuber, pretty good.
Okay, yep.
But it's basically like he makes a really good point that like even though this is about that specific song, it's actually probably much more pertinent in the oncoming age of AI because like
Mm.
can you copyright kind of like a feeling of a song, right? Because it's not
Right,
like
right.
not the same words, it's not the
Yep.
same, but it's like definitely in the same style, but like that song, like the Marvin Gaye song is like basically defining the
Mm.
style. And so like
Yeah,
that does have some implications, I think, going forwards.
yeah.
It seems for now AI is going to win the day.
Yeah, well, that I coined a new term the other day on
Oh,
Twitter. I just
oh
sent
yeah.
you a link.
Okay.
Anxiety or anxiety,
Oh,
AI
there's AI in there.
anxiety. You know, it is the feeling that you have when you think you may not have chosen the best, most optimum AI tool for the job.
That's
Because
not
there's
bad. I
so
like
many
that.
AI tools. Like there's a dozen
Yeah.
new AI tools coming out every
Oh
day
yeah.
now. It is
Yeah.
insane. And it's like,
Yeah.
which one do you pick? Oh, I've got this task, but or have I picked the right AI tool? Is
Yeah.
this
I
one
think
gonna,
the
So
only redeeming factor is that
yeah,
there's not really a whole lot of like skill building that goes into each new one. So
right, yeah.
that part's good.
It's just but there's thousands of them, literally thousands
Yeah.
of AI tools. It's just and it's only going to get worse. It's just nuts.
Yeah. It
So
is.
which one do you choose? Which one's the best for your task that you need doing?
Yeah.
There's a
That's
hundred
true.
choices now.
I
It's
mean,
just
it's
nuts.
coming for us, Dave, over time. I
Yep.
think it's all about like existing in the corners for now, right? I mean, so
No.
that is honestly part of the reason. It's not like a true concern, but I am interested more in like continuing to get better at firmware and stuff like that too, because it does
Mm.
feel like the board layout piece. It's much more like ubiquitous, which is actually great, I think, from an access perspective, but also like if I was going to be hired for my services in the future, I'm
Hmm.
not sure it's as hireable. I guess you always have like people that you always have your reputation and like being able to solve problems. That part's not going away, I don't think. But I do wonder about the hardware versus the firmware piece. It does seem like the firmware piece is harder to solve in a lot of projects, or there's more stuff there.
Yeah.
That's my gut
But
feel.
yeah, but you still need a program. You still need a good programmer to make sure to combine it all together and make sure the output from the AI is
Oh,
is
sure,
good,
sure.
right? So you still need those
Yeah,
skills,
yeah,
but
yeah. Some kind of like
yeah,
judgment engine, right? Whatever it is,
yes,
it's like,
right.
yeah, I think AIs will have fever dreams, and I think they've achieved the task, but they're, being the third party in that case is still
You
valuable,
need
I
to,
guess.
yes, there needs to
Yeah.
be an adult in the room, so to
And,
speak.
and there you go. Yeah, yeah,
You need to be the AI adult. And here is
yeah.
my tip for every youngster out there, right? There is a new technology that comes along once in a lifetime, once or maybe twice in a lifetime. AI is it, right? So if you are not getting on this now, you should become the expert at whatever company you're working at. You should become the expert. Spend every waking hour. I'm not kidding. Spend every
Hmm.
waking hour learning all the different things that AI can do. Become the expert. So when your company goes, oh shit, we have to do something with this AI,
Hmm.
or how can we optimize things? You can go, hey, I've been doing all this work on the side. I'm an AI expert. I can show you how it does this,
Yeah,
this, and this, and this, and boom, you'll be the most valuable employee in the company.
that's interesting. It's not a bad. I don't disagree with it, but like when you say an expert,
You can't lose. You can't lose by spending your time
uh,
learning all the different stuff that AI can do.
yeah, but like,
You don't necessarily have to be an expert. You just need to be smarter than you need to know more about AI than everyone else in the company. That's what I'm
yeah,
saying.
you just got to be faster than your slowest friend, right?
Yes, exactly. So no, you don't have to be some absolute guru, but you will
Yeah.
appear as a guru, right?
No, I know. But what I'm getting at here is, do you think it's learning how to program and build your own, or is it just as a user?
Doesn't necessarily matter. You just have to, even if you just know which tools are applicable to which
Mm.
application and how to utilize them, that is more than enough skill. That's more than 99.9% of people who work at your company will know. right? Is how to use a particular AI skill for a particular AI tool for a particular purpose, and then how to drive it. And if you know
Yeah.
that,
Okay. Yeah. Yeah.
you are invaluable. I guarantee it.
I don't know. I guess I'm discounting the general ubiquity of all these things too. That like to truly stand out in that case, it doesn't really just knowing the tools doesn't feel like you would stand out in like a large organization that has potentially other young people there.
Ah,
That's the main thing that I'm
yeah,
resisting it
but
for.
what you're not counting on is that most people are lazy.
Most people are
Okay,
lazy. Yeah,
most
that's
people
not
are
bad.
lazy.
Yeah.
You can be
That's a good point.
you be the person who's put in the hard yards
Yeah.
at night on weekends, learning.
Yeah, doing projects for yourself.
Doing projects for yourself. Showing
Yeah.
stuff. Have stuff that you can immediately show them.
That's a good point.
That you know what the hell you're talking about, and you can actually apply this skill immediately.
Yeah, that's not bad. Okay.
Right? And trust me, you'll be the most valuable person in the company. Because every company is going to have to get on the bandwagon. They're going, oh, how do we? But they have no idea how to use it, right?
You'll be the Ryan Howard of your company. You'll go from being the temp.
Who's that? What's Ryan Howard?
Oh man, that's a U.S. office, the office from the U.S.
Oh right, okay,
it's a reference to him.
Right.
Sorry.
Yep.
The people who knew it though, they were like, yeah, I know that reference.
but the thing I'm saying is that this is like a once in a lifetime thing. Very rare. Like the internet was one of them, right? If you got on the early internet, stuff like that, right?
Right.
Name another thing, right? Well, it'd be personal computers in the late 70s, early 80s.
The printing press,
right? Yeah, personal computers, desktop publishing, the internet. Like I'm not thinking of much else, right?
Right. So I guess this is another piece of my resistance here. Is that like, okay, so let's talk about the internet, right?
Yep.
Some people said, hey, I'm on Usenet forums. I know how to use this stuff. And they stayed in their company and they said, yeah, I'm the guy. And then they became the IT guy.
Right.
Other people did that. And then they went and started a business and sold to those IT guys and they're billionaires.
Oh,
you know
no,
I mean?
sure. Yeah.
So those kind of like, I guess that's kind of just the stuff that's going through my head. I'm not saying that people should quit their jobs and go and become AI.
But you need to get on this now so that either you can branch out on your own, right, and form your own company or form your own products or whatever it is, or you can be the most valuable person in your company, right? Either way is fine, right? I'm not talking about how to become super rich. I'm just, how to secure your future.
Yeah.
Right? And this is a once in a lifetime opportunity. Do not pass it up.
If we are molding young minds, Dave, maybe we should tell them to shoot high, and then worst case scenario, you become the IT guy.
Oh, maybe. Okay, yeah. Well, that's why work on stuff on your own time, and then this is
maybe that lands.
Midnight engineering stuff, right? This is classic midnight engineering we've talked about forever, right? Yes. But do it for AI because AI is the new game changer, right?
Yeah.
Be the most valuable person in the room when it comes to AI.
Yeah.
It will not be a waste of time spending your time on that, right? Don't go out and party, kiddies. I'm telling you, right? Spend your waking hours learning AI.
I think what we might be deluding ourselves is that anyone under 18 or even under 25 is listening to the show right now. But if they are, first off, you're awesome, and also you older folks, you're awesome too.
No, but how many college students would we have, right? Tons, I'm sure.
I don't know.
Right? Heaps.
I don't know, Dave.
Right? Stop partying, learn bloody AI, right? Get it. Don't be a lazy bastard, right?
Yeah.
Yep.
Yeah, that's true. Go hard. Yeah, no, I agree with that pace. Yeah. I don't know if I would have listened to it in my younger days.
I totally wish I had that advice back in the day.
Yeah.
And just learn it, go hard. Yeah. I wasted so much time just bumming around, being lazy, Yep. Totally regret that. Waste of time. Yep.
Dave, you can't regret it. It brought you here to this very moment.
Yeah, I know. But every step I did.
To the awesomest co-host you've ever had.
Right. I am not worthy. I am not worthy.
Yeah. No, that's what I was going to say.
Love it. Anyway, that's my tip for this week.
Well, another thing that I'm interested in terms of like future trends, I was just watching Wendover today, had a really interesting video about manufacturing in Mexico.
Oh, I have not seen that one yet.
It had peaked. Yeah, it just came out today, and it piqued my interest because it was I think the title was like Mexico is the new China kind of thing. And that's like a buzzwordy kind of thing that's been written over and over again about
No, I've been
Vietnam and
hearing that for
India
years,
and
yeah.
Brazil and all of,
Yeah.
like lots and lots of those. But I think, he lays out a case for the logistical aspects of it in relation to the proximity to
Oh,
a very, very
just
large market.
simply being close
Yep,
is
totally.
that is like the
Yeah.
border, right? It's right there.
Yeah. Yeah.
Sometimes it's miles away, right? If you're talking like San Diego, it's like just
Sure.
you can just walk
Yeah.
over,
You
right?
literally walk over the bridge. Yep.
Yeah,
Yeah.
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 It's like
Yeah. It's nuts.
yeah.
Yeah. And what I was wondering though is like I would be I would love to hear from listeners is if you are doing manufacturing in Mexico and you're allowed to talk about it, of course, just like what's it
Mm,
like? I mean,
yeah.
like first off, I felt like a little validation. I'm like, oh yeah, I'm learning Spanish and not Mandarin right now.
Yeah, right.
But that's actually because I don't feel like I could learn Mandarin, and I don't really, like it's a
Yeah,
lot easier
I would
to.
have that advice. I wouldn't be learning Mandarin. I wouldn't
Yeah,
bother. Yeah.
did I ever mention on the show? I think I probably mentioned on the show that I took Japanese in college.
Maybe. Yeah.
Yeah, it was like this
Right.
this trailing edge advice of like, growing up
Yeah,
in the
that
90s,
that
people are
that
like,
would have
"Oh
been
yeah, you got to
trailing
learn
edge
Japanese."
when you're
Yeah.
in college.
Yeah, I
The
was in the
Japan
early
thing was
2000s.
yeah, like
Yeah.
Japan was huge in the 80s, right? Japan, well,
Yeah. And through
basically,
the 90s, I think too, right? I mean,
yeah,
like
maybe,
chip
yeah,
chip
early
stuff through
early
mid
90s,
90s,
yeah,
right?
yeah,
I mean, like
yeah,
until
yeah, for sure,
until a lot of the stuff shook out with like the memory wars and stuff like that. I feel
right,
like yeah.
yeah.
And yeah, that was I also like Japanese culture, of course, but it definitely was on the back of like, oh well, I'm doing engineering. This would be a good idea for like my career too, sort of
Mm.
thing. Yeah,
Well, maybe that's
you know.
something I can ask Steve Sangi next week.
Ooh, a little teaser there, little
Yeah,
teaser.
well, we have him booked. We have the CEO of Microchip, Steve Sangi,
Yep,
will be on next week. So,
yep,
yep, I'm going to record that on Tuesday, yeah,
yep.
assuming
That's
nothing
very
goes wrong.
exciting.
Yeah.
Yeah.
So, yes, send questions. I do have a Twitter thing down below.
Oh,
And,
great, 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 great.
and of course, I ask that question. Everyone bitches me. Everyone bitches. When can I get my parts? When can I get my parts? Why does your software
Oh
suck? I can't ask him, why does your software suck? I mean,
no, I think
it's like,
that'd be kind of rude.
yeah,
I think you could ask that in a nicer way of like, what are
right,
some resources
maybe.
for
Yeah.
engineers looking to
Yeah.
learn your unique style of software?
Right, I can ask ChatGPT for a
Yeah,
nicer
for a
way to
nice way
say
to
it.
nice way to do it. Yeah,
Yeah, right.
yeah. I think even if you asked really rough questions, like he's the CEO, he knows how to like, they've all had media training too. They know how to
Yes,
like get
yeah,
around
exactly.
questions and
They
stuff.
know
So
how to
yeah,
get around questions.
yeah.
Yeah, they know how to
Right. No
word them
hard hitting
properly.
answers for hard hitting questions on the Amp Hour.
Mm,
We're all about
yeah.
softballs around here, folks.
Oh,
But yeah,
boy.
what would be
Yeah.
what's the thing in relation to like Japan and China?
Yeah, I
with
don't even know
microchip?
where they're making. I assume they're still making some chips in Arizona, right?
Yes, yeah.
Are they? Yeah.
They are purported to be growing their fabs, I
Oh,
believe.
okay.
I think
Yeah,
they were
see,
part of the CHIPS Act. So
I have
that
to
I
do
think
some
would be a good
research on that.
question.
Yep.
CHIPS
Definitely.
Act and just like what are their plans there.
The CHIPS Act and everything. Yeah. Yeah,
Yeah.
definitely. Yep.
I'd also be interested about like, just like how's it going with eating Atmel?
Yeah, no,
Are
totally.
they digested yet?
Are they fully digested? Yeah.
Yeah, I mean, and like I think that's got to be tough from a, like you and I still talk about Burr Brown parts, right?
Oh,
Like
yeah, no, that's
TI
hard.
ate them
That's
35, 40 years ago, and like
yeah.
there's different operating groups, there's geographical differences. It's
Yep.
basically like there's the European Union, right, which is this collection of many, many countries in the continental Europe, but like we wouldn't refer to like an Italian person the same way as you would a French person unless you want to get punched
totally.
twice.
Yeah,
Right? I mean, like,
exactly.
like there's just like these cultural differences that like persist and
Yep.
people take pride in. And it's like, you just, it wouldn't be smart to do that culturally, I think, within a company either. So
No, totally not. No,
I'd be interested
that's
about
why
that dynamic.
there's so much
Yeah.
legacy in these, because they all get gobbled up. We've covered it here on
totally.
the Amp Hour. Like, it's just insane the amount of companies, semiconductor companies that have been gobbled up. But yeah.
Yeah. So that would definitely be interesting. What else would I ask Steve?
Well, I can ask him if anyone's attempting to buy microchip.
Yeah, I'm sure he'll be right out with that one.
Yeah,
Don't worry
right.
about
He'll
it.
be
Yeah,
right on
yeah.
that, Yeah.
Yeah. Yeah.
Oh, boy.
Yeah, maybe I would be interested actually what it's like with a public company, like for, they make very complex things, and like,
Yeah.
and then you have people that are on Wall Street, it's a public company, and just like, what is it like interacting with investors? And do they have any semblance of the actual difficulty? You know, is it just like, hey, money machine, crank out more money? Or is it like actually that there's actual interest there? And
Yeah.
like, does that drive business and growth and that sort of thing, you know?
One of my big questions is going to be supply chain, right? Because people think,
Sure,
oh,
sure.
us engineers,
Little
right?
guys.
We need the chips, right? We think the chip is the bottom. Like if we can't get our chip, right? That's
Yeah.
to us. We don't care about the rest of it. Can we get the
Right.
chips or not? Right?
Yeah.
But then the
Give me the
companies that
chips.
manufacture the chips, they're going, oh well, we need our silicon, we need our
Yeah.
our wafers, we need all the chemicals that
Yeah.
go
Yeah,
into
totally.
making them. Like that's a supply chain in
Yeah.
itself.
Yeah. It
So
ripples. Everything ripples. Everything
everything
ripples.
ripples right from the raw
Yeah.
material upwards. So
Yeah. Yeah.
if they've got supply chain problems, like we think they're the bottom of the supply chain. It's
Yeah.
turtles all the way
That's right.
down, right?
That's right. Exactly.
So,
Exactly. Yeah. Right.
oh boy.
We
Yeah.
can't process the wafers until we have more machines, and the machines
Yeah.
need wafers that are inside of chips. And oh my God.
So yeah, I think I don't actually know that. Like, why is there a chip shortage? What is stopping you making the chips? There must be something further
Oh,
down the supply chain that's stopping them making it. Yeah, I know it was the whole COVID thing and they did predictions wrong and shut down. Then there was sudden demand and they couldn't get them and
yeah.
the big
Yeah.
companies were buying them up. But is there something beyond that? I'm just curious.
I bet that's pretty big. Yeah. Yeah.
Mm,
It's interesting. I mean, like, and also, like, Steve's insight into the whole supply chain, too, right? I mean, like, the CEO needs to know a lot, but I'm
yeah.
guessing that it would be a big waste of his very expensive time that, if like an operations manager in the silicon
Right.
sourcing was like, like he's giving him like one sentence for the investor meetings versus like, like, Steve, can you help me solve this problem, please?
Yep.
So
Right.
the fact that he's talking to you is actually like, that's we should ask how much it would cost. Like, what is he really giving up? What is the opportunity cost to come
Yes,
on the
what
amp
is it?
hour?
Well, I was struggling to get the full hour. It was like, oh, we might be able to
Yeah.
get you half an hour.
Yeah.
It
Oh
was
man.
like, but
We'll take
apparently,
whatever we
yes,
can.
yeah.
Just
We'll
how about
take
this?
whatever.
Whatever he doesn't fill into the full hour, then it's gonna
Yep.
be me and you filling in with like
Yeah,
like
extra.
an after game show, like a sporting event,
Right.
and we're just gonna fill in the details. So the more time he
Yeah,
gives, the better it's gonna be for the how they look.
got it. Boy. Anyway,
We'll
yep.
take whatever we get though.
Yeah,
That's
yeah,
great.
we totally will. Yep.
Yeah,
Nah, it's
that's
all good.
cool. No, I'm excited.
Right.
That's really
Yeah.
great. Yeah, it is. I mean, I don't know. I don't know if you've been seeing stuff. We've been talking about it a little bit. I guess when other Dave was here in Durham and we recorded, he was talking about it. He's a consultant, just kind of like general loosening up of supply chain. And I forget who was on before Dave. We've been talking about supply chain a little bit though, and it seems like it is loosening up.
Right.
That's my general feel, and also like my digi-keying.
Depends on your luck. Like,
Yeah.
I hear people still, no, my business is totally shut down because I still can't get parts.
Really?
It depends on what part you've actually got. And,
Yeah.
you
Yeah.
know, what
I dropped
part,
in on the Adafruit live show yesterday too. It was Phil and Lamore were talking about like, oh, we managed to get this one reel and we're able to make this product now. And that
Right,
felt
yeah.
like, kind of like that stop start nature of it too. That felt
totally.
very realistic too, of just like,
Yes.
you just do what you can as you can and just hope you have the other parts that are necessary in the moment.
Exactly.
But I think that's
Yeah.
how like the train kind of starts back up, like it has to happen like that. And I think the thing that's really helping a lot of the things shake loose is people not scrambling, and they can go back to building like they had before, and like then they can start to build, so now I'm not building with the parts that you needed, and you're not then scrambling and building with the parts that someone else needed, and then on and on and on down the chain, like how it ripples like that too.
What's all this I cubed C rubbish?
I cubed C. Oh, that is a new standard that is on our list.
Because there aren't enough standards. So we'll make a new standard and that'll be the standard, the XKCD thing.
Well,
anyway.
This is just it's the next one, Dave. It's the
this is brand new. Is this analog device? What's this? It's on the Planet analog device. It's the i3C, which I'll call the iCube-C.
Right. It's
because this is an update to I2C. Right. This is update to the Philips I2C standard.
That's right. Yeah. So Philips was the original, and it was licensed at some point, but it's obviously
it's a trademark thing. If you want to use the I2C name,
Yeah.
then you have to pay. Well, I don't know if it's still the case, but it used to be the case. You had to pay them a trademark,
Yeah.
royalty fee, and you had to license. And back, yeah, as you said, like they would give you a licensed address that you could use and all sorts of things.
Mm-hmm.
But yeah, so a lot of companies will just put it. It'll just be like a generic two. They'll just call it two wire or
Two wire
something like that.
interface,
Yeah,
TWI.
yeah,
Yeah.
yeah,
Yeah.
exactly. But it's
Yeah.
actually I squared C, right?
That's right.
They
Yeah.
just don't
Yeah.
want
It's
to
all the same thing. Yeah.
use the trademark. Yeah, yep. So this
Yeah.
is I squared C. So who's come up with this?
This is I3C. This paper is from TI,
Oh, it's
but I'm
right.
guessing I think the MIPI Alliance is actually doing it. So
Oh, it's a
MIPI,
MIPI, right? MIPI's the
yeah,
thing that a lot of
display folks, right?
cameras use and stuff, like a serial
Yeah, that's right.
interface for cameras.
Yeah. And so I think I think that's the other thing that's kind of interesting too, is that like back when Philips did the I squared C, it's like Philips was just so big and monopolistic, and they, companies didn't really do this whole standard thing anyways. And now it's
Yeah.
like, this is a little bit better of a art, of working in alliances and that sort of
Yes.
thing. It's not easy, but
No. For those who want a history lesson of how I squared C started, it was like Philips, of course. This was back in the days of television, none of this digital rubbish, right? Analog television. Philips made a chip for every aspect of a TV. So you'd have the tuner chip, you'd have the filter chip, you'd have you'd have the CRT driver chip, you'd have the on-screen fancy pantsy ones later in the day. You'd have like an on-screen display chip, and you'd have all these chips. And a TV would have dozens and dozens of these chips.
Yeah.
And
Right.
Philips needed a way. Philips came up with the I squared C bus so that they could join all these chips, a standard protocol to join all their own chips together. That's how it came about. It was the standard for TVs.
Right.
Every TV used the I squared C, but yeah.
Whatever you do is a standard then, because you just keep using it internally, and then other people are like, "Ooh, I want to play."
Yeah, you just keep using it internally. And then all the other manufacturers went, oh, well, I would like to talk to the I squared. I would like to make a chip that talks to the I squared C bus, please. I want part of that action. And they went, okay,
Exactly.
we'll license it to you. And, and then it just,
And I think, luckily we are getting back to the age of chip companies buying each other and being massive enough, so they just get to make their own standards again. so why not? Yeah, we're back there.
So I don't see any technical detail in here. Is this still like a pull-up base? Because I can't, it's 33, like in ternary mode, it's 33 megabits per second. I have a hard time believing you could do that without like an active pull-up or something. Does it use an active pull-up? Because basically the speed limit of an I squared C bus, you should know this, constant, right? This is bread and butter, is that it uses usually a 2.2K pull-up resistor, right? But then the capacitance of your line limits you've got an RC charge constant, time constant, and that limits the slew rate, and that limits the speed of your bus. So is this like an active pull-up? I assume it's like still a two-wire thing. I don't see any details.
Yeah, I just linked you a wiki page about it as well. I think it is still
right, there it
pretty. Let's see, 2016. There was some early stuff. Oh wow, it's been around for a while actually.
Oh, there's a Venn diagram. It's half I squared C and half SPI.
It seems like this is still. Yeah, so it seems like this has been a long time coming, but it definitely is like a superset type of thing. Yeah, like Dave mentioned, the superset or the Venn diagram shows it like crossing over with SPI as well, which is kind of nuts. But
it's part of the new DDR5 standard. That's interesting.
Yeah,
that'd be for memory chip configuration or something, maybe.
Yeah, the thing that I don't understand about all this stuff though is, it does seem like they're just trying to force more and more stuff on. They're trying to make like a mid-range bus, which is still like
it's
driven.
like
it's
a
not
jack
LVDS,
of all trades.
It's
exactly.
And so like, I don't know. I just think I squared C is like, it's going to be slow, and it's going to be it's not super noise resistant.
But that's all you need. But a good lot of time, that's all you need. You just need I just need to update a few bytes in a real-time clock chip or something. I don't know.
Exactly. I need to take a temperature on some other part of my board. I need to get that across the board, and I can just put pull-ups at either end, and I'm good to go. I can slow down the clock if it doesn't look good, right? So like that. But it does get, I mean, by yours truly included, like it does get bastardized quite often and like loaded down with lots and lots of sensors, and there are limitations on addressing as well. So if you have the same sensor, you don't have address switching, you need to insert like a I squared C controller or a switching chip that handles that sort of stuff. So it does get overused a little bit sometimes, but I'm not sure how then this plays into it as well.
Right. I still can't find any info on the hardware layer. I'm not.
Yeah.
Yeah, it's there somewhere. Meh.
Yeah.
Whatever. Yeah, it's trying to bridge the gap between Spy Bus and I2C, and it's like, do we need to? I don't.
Well, and I think this kind of comes back to like the Davism that's like it doesn't exist until it's on DigiKey, right? And it's like
right. Yeah.
And I think that's a pretty good rule, especially in this case. Like we'll have to worry about it when we see it on microcontrollers and parts that we actually care about.
Yes.
I'm actually much more concerned about, what was it? Oh, on the new Nordic chip we talked about a couple weeks ago, the 54H20.
Right.
So they don't have 3.3 volts. They only have one bank out of all of their IO that has 3.3 volts.
Oh, one bank? Is that it?
One bank, yeah.
Usually it's chip wide.
I think it's because they're moving down on the size of the like they're on like
That's
22 nanometer now.
Right.
And like just starts to not be realistic. So then you have to go external with like a power controller. And that worries me a little bit more than this sort of stuff, you know, like
right.
Just because and it's like sensors are also going that way. It's not like there's not sensors available, but just like the multiple power domains. Like I'm just finally getting my brain.
It really got annoying when, you know, everything moved from 5 volt to 3.3. It's like, you don't have 5 volt compatible IO anymore. That's annoying.
Right.
And
if we have anyone out there listening who's like, oh, I designed cell phones, or like I'm on like leading edge stuff, they're like shouting right now.
Tell someone who cares,
but like,
you know.
Yeah, exactly. It's like, you know, like
we're just working on our industrial widgets. You know?
Exactly. Like slow and slow, baby. Low and slow.
We've just feels like we've just gotten used to the fact that, it does it. You just assume everything doesn't have 5 volt IO anymore, and that's fine, right? I seem to have like just accepted that now, you know.
Yeah, and there are still some specialized ones, like the new Arduino thing that's using a Renaissance chip that's 5 volt tolerant. But I think it's also like they chose it because they know people are going to be trying to shove 12 volts in.
There's all backward compatible. And there's all backward compatible boards and whatnot, hats or whatever they are.
Yeah. Shields.
Shields. Things.
Yep. Yeah.
I don't know. What's the world coming to?
Well, you know, just more and more standards. I've been playing around a little bit with CAN, which is an old standard as well.
Oh, you're in the automotive. That's, to me, CAN is like, it's just in cars and that's it. It's like...
That's a lot of it, yeah. But it's also like, it bleeds over into other...
Yeah, it can do.
Mobile industries, basically, like things that have... Basically anything that has like a motor controller and a battery system as well, it's probably going to have a CAN bus.
Okay, right. So like a humanoid robot or something might have a CAN bus,
robots,
for example.
Scooters, that sort of thing. Yeah, it's all the same kind of stuff there.
Yep.
I'm not doing like a lot of active work on it. I'm mostly like reviewing someone else's work, but I played with it a very, very little bit. And what a hot mess. Like, there's no standardization at all. Like, so like, basically, I think this is maybe the same kind of effect that we're talking about here, where the companies are just so big and I think secretive as well. You know, think about like automotive companies that they just, you know, so CAN is basically like it is the physical layer, and I think one layer up from that in like the OSI diagrams.
Basically, well, in the automotive market, they're playing for all the marbles, right? You're not going to share. You're not going to be friendly with your competitors, right? You're going to lock in that standard for yourself so that the car designer has to buy your chips, right? They don't want a second source, right?
They write all of the rules for their subcontractors and all like the OEMs. And the OEMs might make the same thing for Toyota and Mitsubishi, but they might be completely different communication standards. It might be the same hardware with completely different firmware.
Right. Yeah.
And like, so then, you know, and everything just is like shouting on the bus. You know, it's just like such a noisy, rude bus. Like, you know,
noisy, rude bus. It's the Ethernet of serial buses, is it?
Yeah, right.
For those who don't know, the Ethernet standard is incredibly rude. It's just like you can jump on there anytime you like, and then they'll tell you to bugger off, and then you come back at another random time and try again, and try to annoy the bus again. And if it happens to be available, yay, winner. Otherwise, you keep trying at another random time. It's bloody. Is there a ruder bus? Is there a ruder bus than the Ethernet? Rude buses can be the name of this episode.
Yeah, I like that.
What do you think? Rude buses.
I like
it.
Yeah.
And you can have like a bar. You can do the mid journey thing and get a. Well, after this, we'll
I'm
we'll
way ahead of you,
try the
Dave. I'm
mid.
way ahead of you.
We'll do a mid journey battle and see who can generate the best
Okay. All right.
rude bus photo. Oh boy.
Yeah, I think with Can, I've used a similar kind of thing on like a bastardized RS-45 in the past, and it was like the
Right.
same kind of
Yeah.
thing where it was like basically lowest address wins, and so at least Can is a
Okay.
little
Yeah.
bit kinder in that like you basically like everybody shouts their address first, I think,
Yeah.
and then whatever's listening for it, then you respond. It's kind of like somewhere between an Ethernet and a I2C in that there is specific addressing though as well.
Right.
Yeah.
Hmm.
Yeah. So it's I hopefully have more to report later, but it is an interesting space to be in for sure.
Oh well.
Yeah.
What else we got this week?
What else do we have?
Oh, I do like Practical Engineering's video on how sensors keep bridges from
Oh yeah.
from
Yeah.
from collapsing. So have you worked with strain gauges at all?
No, just like not in any practical context, just like
They
academic
are
type
very
stuff.
cool. Strain gauges are very cool. Like you can
Yeah.
super glue them to I've super glued them to all sorts of weird and wonderful things, and
Mm-hmm.
or used epoxy or some other thing to attach them, and you can measure the stress and strain on your product. If you've got a
Yeah.
physical product, then learning how to use strain gauges is
Mm-hmm.
a really useful thing.
Yeah.
So
Yeah.
yeah,
Yeah, and he's showing it like with a kind of an industrial. So he is actually epoxying it. He shows an I beam,
yep.
and then he stands on the I beam and he shows the deflection, and it's like much more than I would have guessed. Like
You can get really minute deflection. You can measure really,
yeah, yeah,
really
exactly.
minute stuff. Yeah, with a strain
Yeah.
gauge. They're really remarkable. For those who don't know what a strain gauge is in this instance, it's basically a printed resistor in like a
Mm-hmm.
zigzaggy pattern, a big, back and forth zigzaggy pattern thing that's like on like a mylar sheet. There's many different ways to do it, but like often the ones you'll get are on like a mylar sheet. So they printed this resistive thing, and then you glue down that mylar sheet to your steel beam or whatever, and then when that mylar sheet stretches, then the trace on there stretches and it changes its resistance. So you put it in a Wheatstone bridge thing, which is very good. A Wheatstone bridge of configuration, of course, is very good at
Mm-hmm.
picking up minute differences in a resistance, and then it will give you a differential output, and then you can amplify that, and you can get it just changes the resistance ever so slightly.
Right, and it's already pretty high resistance to start with too, isn't it?
Yeah, they're
Yeah.
yes, they're quite high.
So like
Oh no,
fractionally,
some of them could be hundreds of
yeah.
ohms. It
Oh, okay,
depends,
all right.
right?
Yeah.
Yep. And very cool. Very cool
Yeah.
strain
What did you
gauges.
use? So when you said you did it for products, like what were you measuring the strain on a product?
Oh, because we were manufacturing towed array streamers for not only, I worked on submarine ones. I've worked on ones for the
Oh, I can see that.
survey in
Yeah.
oil and stuff like that. So they drag
Sure.
behind a boat. So everything is torsional and everything's flexing. Everything's
Uh-huh. But is it
so.
the case that you're measuring usually, or is it like the actual circuit board
Oh, it
too?
can be case. It can be strain on wiring harnesses. It can be strain
Oh,
on
interesting.
shells that hold hydrophones and
Yeah, I
transducers
can
and other
imagine
things,
pressure
and
vessels for sure would definitely be
all
like
sorts
a
of stuff,
target
right?
thing.
It's
Yeah.
yep, stress
Hmm.
and strain measurement, and I
Hmm.
actually built my own amps for that. So you build up your own amplifiers. Really precision. So you use a nice analog devices. Differential amp. With bugger all offset, and
Mm-hmm.
really nice
Yeah.
stuff. The chip is like $20. And, yep,
Yeah. That's
yeah,
great. That's
yeah,
awesome.
really fun stuff.
Yeah, that's
So
cool.
anyway, I will have to watch that. That'll be my lunchtime
Yeah, that's a
video
good one.
today. Yeah.
Yeah, that's a good one.
Anyway.
That's a good one.
Yep. Very, very. Once again, that's another tool to have in your toolkit. If somebody goes, like if you're working at a company and you happen to be manufacturing some sort of physical product, you can go, oh, I can measure to see at what point that fails, or at what, see if it has any impact, or things
Mm.
like that. So yeah.
this is gonna sound stupid, but I remember the
Yeah,
first time that someone like just had a thermocouple and they were like, "Yeah, I'll just measure I'll just like glue it to this thing and just measure the temperature." Like it was
yeah,
like a
yeah.
chip or something like that. I was like,
Magic.
oh yeah, you could just do that.
You can do
Like
that. You can learn
I,
so
I
much.
know that's like
Yeah,
like a thing that now I'm like, yeah, of course you would. But like then I was like,
yeah.
wait, you can just do that? You can just measure the temperature like that? And yeah, you can. It's actually a really good way to do it.
Can we come up with a list of valuable skills that you wouldn't, yeah, like,
I have a
strain
particular set
gauge
of skills.
that
If
you
you
may
take my
need.
product, yeah.
Yeah.
If you take my product, I will find you.
Liam Neeson, channel our inner Liam Neeson. And for those who don't get the reference, Taken
Taken, of course.
movies, yeah,
Yeah. Yeah.
right. And
Classic.
yeah, like thermal imaging, thermal measurement,
Mm-hmm. Yep.
stress measurement with these strain gauges that we're talking about. I've done videos on vibration measurement using accelerometers and stuff,
Oh.
right? Very useful skill for, is my PCB going to survive transport? Is my PCB going
Oh,
to
that's
survive
interesting.
in an operational mode, right? Huge, valuable skill to have.
How would you do that now? Like just like
Exactly the same way. You would glue an
tape an
accelerometer,
accelerometer to
super
it?
glue. You get an accelerometer, a little miniature
Yeah.
one, and you would super glue it to your PCB, often in multiple locations, often in multiple orientations, because you want to
Mm-hmm.
shake it in different orientations. But you can use just one if you want, and then mount your board in different configurations when you shake
Mm-hmm.
it. Vertical,
And you like
horizontal, diagonal.
wire it off board and just measure it like out of a DAC or something like that?
Yeah, you send it into a charge amplifier, and then you send that into a dynamic signal analyzer, which then you can get the frequency sweep of, so you know the resonant point of your PCB, like how
Oh,
it's
interesting.
mounted. So your PCB,
Got it.
oh, I've got this giant PCB and it's only got 4 mounting points in the corners, and I've got this real heavy transformer in the middle. Well, dude, you're going to come
Yeah,
a
right,
gutser,
right.
right?
Resonant frequencies, yeah, for sure. Yeah.
Just transporting your product on the truck to go to your customer can damage it,
Mm,
right? So
yeah.
there are standards for all these things. There's standards for transport of products, and you can test that your
Mm.
product meets those transport standards by rail, by road, by air, by ship, and all sorts of things. Right?
Yeah, that's
It's
great.
a
That's
huge
great.
rabbit hole there, and if you've got the skills to do that, you're a valuable employee, right?
Yeah, that's great. I think
So
I forget where I was talking about. I think this might have been at work, but I was talking to someone about like the importance of getting off your bench because like it's so easy to like lull yourself into a false sense of security of like, of course, I've like done all this testing on my bench and like it works great. But then
right,
like you
right.
said, like, it's in your pocket and like, oh, a corner, like exposed or like something on the board shorts to the case and the chassis and then it just like shorts out or something.
Or simply getting it outside. Oh, it's in the sun.
Yeah.
Oh,
It's
it's
in the
40
sun, right?
degrees
Exactly.
now.
Yeah,
Oh,
yeah.
it's not
Just
20
like
degrees in the lab. Oh, it's snowing outside. It's 0 degrees.
yeah.
Does my battery
Right.
work? I don't know.
Right.
Right?
And just like I think that would have been great advice to my younger self of just like get it in situ as fast as possible, even though it's not perfect
Mm,
yet. Like
yep.
whatever amount of jury rig I need to do of like super glue and tape and whatever to get it into a real enough situation. That
Mm,
is like that's another skill I feel like
yeah.
that is important because I especially feel like young Chris and sometimes current Chris, there's like that safety of being on the bench and like
Yes. Yeah, yeah. No, totally. Totally.
it's a learned
Yeah.
behavior to like to move it off the bench quickly.
Yeah.
And if you can do that, you're gonna find so many more problems that you're gonna save
Mm,
yourself many late night engineering
yes.
adventures, I feel like. Not the good kind.
That's one aspect of my rather boring career, my boring professional career that I'm actually glad of, is that I worked on stuff that's used in the field, that's used in extreme environments, whether it's the bottom of the ocean, whether it's towed behind a ship, whether it's used on the back deck of the ship in 60-degree hot sun, and also, weird, like whether it's dropped from a helicopter. I've designed products that have to survive being dropped from a helicopter into the ocean, right? Huge impact forces. So shock, temperature, vibration, transport, all these sorts of, temperature extremes, all these sorts of things that, I've had experience in has taught me a
Yeah.
quite a lot of valuable skill. It's taught me the importance
Yeah.
that those things actually happen in the real world. So
Yeah.
yeah.
Yeah. And I think just kind of like to It's almost like being a prepper for your own
Right,
board.
a prepper, electronics prepper.
Yeah.
Yeah, right.
All the things
Yes.
that could go wrong, you kind of just you trigger them. You do
Yeah,
drills,
yeah,
like.
yeah. So, or whether or not you're designing a product for, for that kids use, you'd be surprised
True.
at the abuse that kids
Yeah.
will, put on a product or something
Yeah.
like that. It's easy to design on the bench and everyone comes up and, it works. They press the buttons nice and gently and,
Hmm.
like, yeah.
I feel like having like in situ battery testing too, like with like real use case, so like if you could get it again, like you could do a battery test on your bench
Hmm.
and measure the discharge curve, whatever. But can you also potentially measure it when it's in someone's pocket and they've depressed one of the buttons by accident and like that actually is draining the battery as well because the light's on or something like that? Like all of these other failure modes that are just real world type of stuff. I don't know. How do you get to those points faster and still hopefully measure them?
Right. That gives
Yeah.
me an idea for a video,
Yeah.
actually.
Yeah. I mean, this is a definitely good fodder for video of like it's like a boot camp. It's like a boot camp,
Yeah, it could be like top 5 skills you need to know.
Dave Jones boot camp of measurements. And then you could
Top
actually like
5
put on a hat
engineering
and
skills.
whistle
Yeah,
and
yeah, right. Yeah, right. I think I might.
listen up, maggots. I'm going to
That
teach you how to shake a box so hard your circuit board falls apart.
that makes a good whiteboard.
Nah, whiteboard. Come on, man.
What? No,
Put some
well,
theatrics into it. Come on.
yeah, come on.
Come on. It's
What,
really
this
easy for me to say as
just
someone
blow
not
shit
doing all
up.
the recording.
Right. Yeah, exactly. Yeah.
You should spend a little more time on that, Dave. What do you
Right,
think?
okay. I know, just want to churn out cheap and easy content, Oh, boy.
Yeah.
Anyway.
Yeah.
Yep. Yeah, valuable skills. Those skills that you don't learn these, right? You don't learn these in your typical engineering course, right?
No,
It's
you learn
like
them on site
you learn
from
them on
someone who's
site
already
later.
been through
Yeah.
it. Yeah.
There is no course on vibration testing. Hands up.
Oh, there
anyone
is,
who
but
said,
it might be.
maybe, but it's some niche thing that nobody.
This is why co-ops are important. I think that's because there's one job they're also going to make the co-op do. It's monitoring the vibration test.
Yeah.
I mean, that was many of my friends had that as well.
Yeah, but the thing is, like, if you work at a company, you get work experience at a company, and all they do is design, some little PCB that doesn't get used in, any real any like harsh environment or something like that, then then you're not going to consider any of these things.
See, that's another tact you could take on the video of like things to look for in jobs, like internships, right? That would be definitely one of them.
Okay, that's an
like,
interesting take. Yeah.
Yeah. Because I definitely remember thinking that like I want to go do an internship at Intel, right? That was like the top spot. And then the one guy that did it, he came back and he's like, yeah, I was reading Verilog in a cube for 8 hours a day for all summer.
Yeah.
It's like, oh yeah, of course.
That's right. Duh, of course, So all we got out of that is, valuable Verilog skills, but the
I mean, probably a lot of money too.
Press step money and the prestige of having that name on your
it can. I mean, it totally
resume,
can. It could springboard you into another thing. Seeing Intel on a resume might help the next internship or your first job, whatever. But it also might mean you're just put into another cube.
Yeah, right.
So, yeah.
Yeah. Anyway, I'm gonna think about a video.
All right, we've
around
started the
regard.
Dave engine here. We started the Dave engine.
Yep.
Well, your imagination is spinning. Mine is spinning from yet another antenna simulation from Sam. Is that his name? Sam A.
I think.
Sam A. Yes. So if people saw, I think we mentioned this on the show a couple weeks ago. It was he tagged us on Twitter with like a simulation of a transmission line, and it was like an overlay of a Blender thing, and then he overlaid like the simulation using OpenEMS, and it was like you could see the reflections. Super cool. Well, this new one, I really like this, but we talked about it a little bit as well about whether it's actually useful, is a Wi-Fi.
We talked about this just briefly before the show. It's like, it's very cool to see. What he's done is...
it is so cool to see. Like, you have to go watch this right now. We will link in it, of course. But is it useful in a troubleshooting and or like design context? That's actually an interesting question.
Yeah, that's what I was thinking about before. We were discussing this before the show and going, this looks really cool. And then it dawned on me, what am I actually looking at? Is this useful information to me?
Right. Because I had said to Dave, I said, I would love to be able to see this kind of like visualization of like, so just as like an audio picture here, it's an F antenna and off of like, I think it's the TI recommended F antenna for like a 2.4 gigahertz.
Yep.
And then it's like the waves propagating off of this thing. And again,
Hmm.
it looks so cool. But I had said to Dave, like I've always wanted this in like a smart glasses kind of thing. You could like see this in the world, so you could see waves coming off your Wi-Fi router or your
And then how does it
your
couple
cell
into the
phone. And
receiving antenna is
yeah,
another
right,
thing.
right.
Like, how does it like, yeah.
But does it actually change like your design stuff? So like I think one of the key things that neither Dave or I have is like, okay, now you see this. What are you going to do to make it better or worse? Like that's really a missing piece there that neither of us
Yes.
have. Like we're not going to be like, oh,
We
well,
don't
at
have
the end
the
that 90 degrees
RF
should be 80 degrees,
intuition. Yeah, we don't
Yeah,
like,
exactly. The knack.
apart from the fact that, okay, I'm not going to put that next to a metal object, or I'm not going to
Right.
have the user's hand covering it or something like,
Right.
common
Yeah.
sense stuff like that, right?
Yeah.
But apart from that, it's like, well, I don't know, keep the antenna as far away from metal and humans and other objects as possible, and Bob's your uncle, kind of like rule of
Yeah.
thumb.
I mean,
I don't know.
I think there are some RF experts that would have more knowledge and
Hmm.
use case for this sort of thing. But that actionable intelligence, not for us so much.
It's really more of a skill for if you are designing the shoe phone. You're designing the latest Apple shoe phone, and you have to integrate the antenna on the PCB. You're going to go to town, right? You're going to ride that donkey all the way into town, right? Trying to figure out how like every minute detail of how that antenna radiates,
Yeah.
right? That's super important. But otherwise, I don't know. Yeah, it's cool. But I can't see how how that gives me a practical insight.
Right. Well, I think this is kind of like if we zoom out a little bit from these absolutely gorgeous renderings, and we should just restate them. Sam, very nice job. Please keep making these. I will look at these all day long. But like generally, I think as well, like simulation has tons of value, but again, like then what is your action as a result? I think at this point, this is one of the things where I think I've talked to Mr. Jeffrey Kaiser about this before too, and I say like, well, what do you do then? What's like, where
Yeah,
does the
right.
knowledge? And Jeff's like, look, you got to go back to fundamentals at that point then, right? You need to make
Yeah,
sure you
yeah.
understand your R's and your C's and your L's, and that you understand how signals normally propagate in a best case scenario, worst case scenario, whatever. And I'm like, oh, right. I don't have
Exactly.
that.
Or
Yeah.
I've forgotten it.
I've forgotten it. Yeah.
Yeah, I've totally
Yeah.
forgotten it. There's no way I'm
Yeah.
getting it back.
Yeah.
Right.
Right. And I think the other
Yep.
thing too is that like, so Sam's showing a inverted F antenna here with like the recommended pattern. If it doesn't work, I wouldn't say you go and if it doesn't work how you expect it to, I wouldn't go and start tweaking an antenna at that point. You know what I mean? I'd be like,
Mm.
really be digging in to make sure, like, is it not working because I did something wrong? Because like this is a proven like
Or is it not
reference
working
design over and over
because I
again.
use the wrong dielectric PCB? Is it not working because
Yeah,
other components are too close to
exactly,
it? Is it,
exactly.
have I got
Yeah,
the wrong impedance trace going to it? Like,
right. Yeah, and if you start from something like that well known and like that, like, and something that is in a reference design, not like you can't find it, but like the default assumption should always be like, what did I do versus what did they do? It's not like I need to go
right.
and change the geometry here. It's like, no, I need to understand the actual situation first, and that's actually I think where simulation could help you kind of dig in a little bit more and like
Mhm.
understand more about it, because it's putting visuals to something that is not in the visual spectrum. So that part's always really tough.
You do know that everyone's just screaming at it. Everyone who knows stuff is just screaming at it. It's going, "Oh, you guys have no clue. Just shut up."
Well,
You know?
they ain't wrong. They ain't wrong.
Exactly. But
Oh
anyway,
well.
yeah, good stuff.
Well, we're not making RF stuff that often, anyways.
No, no,
I
exactly.
mostly buy prefabbed RF stuff. Thank you very much. Which is a pretty good solution. The correct answer is buy stuff with SMA cables on it, or SMA
Right,
connectors.
yes, and so yeah. Oh, boy. Yeah.
Yeah.
Okay. What else we got?
I don't know if we have much time for much else. Yeah, I
Because
think
our amp hour is up. Last thing. I did like Electro Boom, former guest,
yep.
made a very cool looking lamp, a fire, like a fire. He calls it a firefight lamp. I guess it is, but it's got little inductive LEDs inside that light up
Hmm.
and dance around, and it's fan at the bottom and flies them around, and it's cool.
In certain parts of the U.S., including where I grew up, they were called lightning bugs, not
Oh, okay,
fireflies.
right, there you go.
That's actually a way you can tell where people grew up in the U.S. is what they call the things that light up their bums.
got it.
Yeah.
And somebody did a smart teardown of. I didn't know Ray-Ban are doing smart glasses.
Yeah, Becky did this. Yeah. Yep.
And what the hell? But why are we doing stuff? I thought they went the way of the dodo. Smart glasses.
I am surprised actually that they're still doing this. Yeah, I mean, because like, what's their name? Snapchat. That other.
What?
Yeah, another Snapchat. Snapchat was another social media thing.
Oh yes, right. Yeah, Snapchat
Prior to TikTok.
God. Okay, yeah, right.
Yeah, yeah. They had glasses as well that were a little bit chunkier than this. The Ray-Ban ones, they look kind of normalish.
Yeah, but what do they do? What do you use them for? What's the killer app? What's the
Actually, Dave, I happen to be holding my Google Glass
your ancient
headphone
Google
jack
Glass
in my hand. It's actually the headphone thingy is actually on my desk for some reason, and
ultimate novelty
with
that
it as we speak.
wore
Yeah,
off.
I think the only thing that was actually good about it was like having something in situ and like that is you don't have to pull there's always the creepy factor. There's no denying that there is the creepy factor, but being able to like capture quasi decent photos at the drop of a hat without pulling out a phone is so different.
Right.
And I'm not going to say liberating because it's not. It feels like that's like a religious experience or something like that, but it's just
a convenience thing.
So much more
right.
convenient.
It's right on your head, and what do you to take a photo? You just double tap the side or something.
Yeah, I don't know. I don't know on the Ray-Ban ones, but it is having ubiquitous like camera is like you get to like have this like
for me that is probably the killer app. Don't make it do anything else. Don't make it do any of the bullshit projection stuff. Just double click the side, like it's always on, sleeping, and then when you double tap the side, it takes a photo of whatever you're looking at, and then it beeps to confirm that it's taken it, so you don't have to check. Right?
Yeah, exactly.
And then
and if you want to check, you go look at your phone and you can download the photo.
You build up confidence in it that, if it's beeped, it's taken the photo and it's got a wide angle, fixed focus, like.
I think that's pretty much what this is doing, right? I mean, because it's trying to kind of replicate just like the eyeballs. It's like you're looking at someone else's eyeballs. That is an interesting perspective from like a filmmaker kind of thing too, right? It's not a common perspective, even if you put a phone in front of your face. And it's not like it gets stereolithic. Yeah,
what's this 3D heat map modeling software they got? They've got like an X-ray kind
I think sponsored the video. That's like a scanner thing.
Right.
Yeah. That is, what is it called? Oh,
how's it? I just want to know how that's working. How
that is a CAT scan. You remember how I showed you a CAT scan at one point?
Yeah. Because they're spinning the thing around. They've got the model, and so they must have mapped it. So they must have put it in this big 3D mapping X-ray scanner box thing, and then got a 3D X-ray of it or something, and they're able to.
Yeah, that is. So I had access to one of those at MHub when I was there, and I think they still have it there. But it was it wasn't a CAT scan. Sorry, it was a CT scan.
Yeah,
and then there was like software they layered on top of it. This looks pretty similar. This actually looks. Is it Lumafield? Is that who it is? I think it's Lumafield.
Don't know. Anyway,
and so I think that's who is doing this stuff.
Okay,
but I think they were one of the quasi sponsors of this video as well.
Okay,
I don't know. I know one of the people that's there. I met one person who's there. So, it's definitely cool software though. Yeah.
Anyway, it's very impressive. Anyway, I'm kind of jealous of. No, I'm sure it's
not cheap. Yeah. Not cheap in the slightest. It would be very, very expensive. But I think like the sort of thing where like, when you need it, you really need it, sort of thing. You know? So like same with that CT scan that I did. I actually got a friend's manufacturing problem board, and like he had like this actually looks like this is not CT scan because doesn't have high enough resolution.
Right.
The one that I was doing, like, it actually had like, remember I showed you like the BGA balls, like you could actually see voiding underneath, you can get 3D viewing and stuff.
Yeah.
Oh, it was
it's magic.
so cool. And like when you need it, you really, really need it,
Right.
So because you're captive underneath parts, Becky does this teardown, and she actually shows there's a Qualcomm chip with like encapsulate like top by memory, so like how they do memory stacked on top of processing chips as well.
Right.
Yeah. So very, very complex assemblies like that. You kind of just, you can't really take it apart at that point. You just kind of, you need something to look inside of it,
Yeah.
So
very cool.
Great video.
Yeah.
I like these kind of things.
I have to watch the whole thing.
Yeah.
All right. Well, that's it. Our MPL's up.
Yeah. All right. Well, good luck with Steve next week. Tell him I said hello, even though he doesn't know me.
He doesn't know you from Bar of Soap, dude.
Please send my regards. And that I like their parts. Blah blah blah. Thanks for being on the Amp Hour.
Right.
And please stick around for a whole hour, Steve. That's the other thing.
All right.
And if you listen, Steve, if you're listening to this, or if one of your staff members is, more likely, ignore what we said about your parts earlier in the show.
That cancellation email is coming through right now.
There it is. Okay. All right.
Cool. Catch you next time.
See ya.